Hello, Namaskar, Vanakkam. My name is Sudhir Sahasranaman and you're watching CBSE with Sudhir. Recording this video after a long time. I've been unwell for over a week now, and if I sneeze, if I cough in between this video, please excuse me. Right. So, science with me, we are looking at this chapter called Particulate Nature of Matter, which is chapter 7 of your Curiosity textbook. This is the textbook that we are talking about. So what exactly are we going to study in this particular chapter? What do I mean when I say particulate nature of matter? Please focus on this word. We are talking about particles. Particles, essentially we mean small particles, the way we understand dust, etc. But there is more to that. Now, let's talk about a story. Now, many of you would have gone for on vacation to different kinds of places, maybe a beach, maybe a riverbank, etc. So we would have all have played with pebbles. In fact, I have got a pebble for you. Have you seen a pebble which is shaped like this? Now, why is it shaped like this? Because of erosion, because of continuous flow of water. This stone has become smooth and rounded edges on all sides. There are no sharp edges. They're all rounded edges. In fact, I've got one more stone which is all sharp edges because that was not found on a river bank. This was collected by me from a river bank. So which is why you see, because of the continuous flow of water, all the sides are round. I'm able to hold it without this pebble, this stone hurting my hand. Now, so when we go to the riverbeds, we collect these kind of stones, don't we? Now, what happens then? Where do these stones come from? What I just now told you. Large rocks in the mountains gradually break down into smaller pieces due to erosion. So this particular piece of stone would have been part of a big mountain at one point in time. From there, because of either water erosion or air erosion. Water erosion, when the water comes and the water hits the stone with great force over a period of time, small pieces from that rock would actually break and convert into smaller stones like this. Or it could be that either because of an earthquake or because of some man-made activity, these rocks may be broken and they may all come down to the plains area. So rivers carry these eroded pieces, breaking them down further into pebbles like this, stones and sand. Eventually, these are broken down into even finer grains of sand and clay. So sometimes these stones, so suppose I sit down today, okay, and with a hammer, I keep breaking it. Okay, I may have to spend an entire day. But at the end of 24 hours, it's quite possible that this particular stone may become like this, completely, small grains of sand, or not sand, but small grains of stone, right? Small mitti ke pieces, it would actually become. So, erosion takes place due to strong pressure of water and also atmospheric pressure. As I said, it could be because of water, it could be because of atmospheric pressure. Now, so what you need to understand after this introduction is that everything around us is made of matter. Everything around us, whatever you see around us, is actually matter. What all are these examples of matter? You talk about air. Air is actually matter. Now, matter, air, of course, you don't see it around us but you can feel it because you are breathing in and breathing out. Water, wood, any piece of wood is actually matter. For example, this piece of wood that I use as a paperweight is actually matter. Similarly, stone, what I showed you, salt, sugar, everything, salt, sugar, air, water, wood pieces, stone, everything is actually matter. So please understand. So we are surrounded by matter all around us. All matter can be broken down. All matter can be broken into smaller pieces. In the case of wood, like this, chalk pieces, you take a chalk piece, you can break it into 2, 3, 4 pieces depending on the length of the chalk. It can be broken. In the case of air, we can break it down into the smallest oxygen atom, right? So that's all possible. So all pieces of matter can actually, all kinds of matter can actually be broken down into smaller pieces. Similarly, when we pass electric current through water, now you may ask, can water be broken down? This is the chemical formula of water. You know, H2O. You can break the H2O into hydrogen and oxygen atoms. These particles cannot be seen with the naked eye. Can you see hydrogen and oxygen with the naked eye? You cannot. But you know that when they come together, they form water, which is H2O. For example, this bottle of water contains H2O, which is made up of hydrogen and oxygen atoms. But can we distinguish, इसमें hydrogen यहाँ पे है, oxygen यहाँ पे है? Can I say that? Obviously, I can't say that. So that is the beauty of this kind of matter. So matter, if I have to look at the definition of matter, matter is everything and anything that occupies space. Water occupies space. Air occupies space. This particular stone is occupying a certain space, right? Similarly, anything that occupies space and has mass, which means it has a certain amount of weight. Now, we know that mass and weight are different, but I'm just using this word for you to understand the word mass, right? So anything that has some kind of mass, right, and would have some kind of weight on earth and also occupies space is known as is matter. Okay, so this is the basic definition of matter that you need to know. What is matter composed of? Let's look at the first activity in your book. Please keep your book open in front of you so that you know the order in which I'm going. I'm going completely in order of your textbook. Okay, so don't worry about that. Nothing is being left out. I'm including even all the activities. So activity 7.1, breaking of chalk. Take a stick of chalk, like you would have seen chalk obviously in your classrooms, and break it into two small pieces like this. Okay, continue to break it. Now this piece, you break it further into two. Then the smaller piece, another break it into two. Keep breaking the chalk piece into two pieces. Grind the smaller pieces. And finally, when you make it really small that you cannot break it further, you're not able to hold it, you then grind it in a bowl, okay, using a kind of a tool into a fine powder using a mortar and a pestle, right? A mortar and a pestle, you keep breaking it. These are the instruments which are needed for that. Now, view the powder through the magnifying glass. Now, through the magnifying glass, get a magnifying glass and look at the chalk powder through the magnifying glass. What do you observe? Each tiny grain observed is still a speck of chalk. It doesn't mean that this has become powder. It has, of course, become powder, but each one of them is actually a smaller piece of the big chalk piece that you had begun to break, right? You kept breaking it and finally you powdered it, and this is what it has become. This is a physical change. That is, from this kind of a shape, right? From this kind of a shape, it has become this kind of a shape. So the physical shape of the chalk has changed into this. From a solid form, this is also a solid, but it is in powder form now, right? Because the substance remains chalk, only the size of the pieces has reduced. Here it was a big piece with which you can write on the blackboard, but with the chalk powder, you will not be able to write on the blackboard, because what will you hold it with? Now, the definition of the constituent particle is something which you need to know. The constituent particle, now this is something which you would have played with when you were younger, right? These are the building blocks. We had it somewhere. I don't know where I probably would have taken it out and showed you. My daughter used to play with this in order to build a castle, right? Now, these are all the different building blocks with which you build a castle in different colors. You know, sometimes you can put yellow here, sometimes of the same size you may find blue, so you can put blue here or red here, but it is an interesting activity that most children indulge in. So a constituent particle is the basic building block or unit that makes up a larger piece of a substance or material. So each one of this is a constituent particle. It is a building block which together alone it doesn't mean anything, but when it all comes together in the correct place, it becomes a total substance or material. So let's look at the second activity, which is activity 7.2. 1 minute, I need to keep drinking water. My throat goes very dry. Oof. Now, let me show it to you so that it's easier and we'll make the class a little more interesting. Okay, 1 minute. I'm pouring some water into a glass. Okay, now if you see, I have poured water, that is H2O, into this glass. Okay, so that's what I have done. Into this glass there is water. Now what I'm going to do next is to take some sugar. Now this is the can of sugar that I have collected from my kitchen. Now I'm going to take a spoon. Okay, I take a spoon of sugar like this and I put it into the water. Okay, I have put it into the water. Now if you see, I don't think you can see it clearly in the camera, all the sugar has got deposited at the bottom, right? The sugar has got deposited at the bottom. Now what I'm going to do is to, with the help of this spoon, stir it. There isn't much space to stir it. Now you see I can see the sugar particles coming up on top. The spoon is a little too big for the bottom of the glass, but nevertheless, let's continue to stir it. So what happens is now you can see that there isn't much sugar. So the sugar has got dissolved in the water. Let me just continue to do that, and then I will drink this sweet water. The water will be now sweet, okay, because it will get dissolved, and it's interesting. Okay, let me just, now you see, you cannot see the sugar particles at the bottom at all. The bottom is absolutely clear. Only 1 or 2 particles are there. The rest has all got dissolved in the water. Yeah, the water is now sweet. Okay, now fill a glass with drinking water and add 2 spoons of sugar without stirring. Taste a spoonful of water from the top layer. So when you taste it, as I said just now, it will be sweet. Stir until the sugar dissolves completely and taste the top layer again. It is sweet, yummy. Okay, now the observation that you need to be concerned about is that initially the top layer does not stay sweet. Initially, when it has not got dissolved completely. After stirring, it tastes sweet even though the sugar particles are no longer visible. Earlier, the sugar particles were visible at the bottom of the glass, what I showed you. But when I stirred it, the sugar particles got dissolved in the water, and now the water was tasting sweet even though the sugar was no longer visible. Okay. Now, what has happened is that when sugar dissolves in water, it breaks up into millions of constituent particles that are too small to see but are still present in the solution. The sugar particles are present in the solution, but they are so small that they cannot be seen. So the definition is that interparticle spaces, the tiny available spaces between the constituent particles of a substance, is known as interparticle spaces. In this case, the tiny sugar particles separate and occupy the available spaces between the water particles. Listen to this carefully. These are the water particles. The blue one are the water particles. So the sugar particles that I stirred and dissolved in the water, they go and occupy the space which is available between the water particles. Between each particle of water, there are these spaces which are available, and these spaces are occupied by the sugar particles, and that means that it has got completely dissolved in the water, which is why the water tastes now sweet. Okay, I hope this is clear. So the interparticle space, the definition of that is the tiny available space, this space which is there between the constituent particles of a substance, in this case water, that is known as interparticle spaces. Okay, is this clear? Let's move forward. Okay, just want to tell you, if you are looking to buy the question bank for any subject, science, social science, Hindi, Sanskrit, mathematics, English, the one that we are recommending is the Oswald Books Question Bank, one for all. Where is it? Let me just search for it. Yeah, this is the one for class 8, the Curiosity one, yellow cover. Class 8 Science Curiosity, one for all question bank. This is what we are recommending. Similarly, there are ones for, let's say, this one I have for English, this one I have for social science, and this one is for Hindi, right? So You can buy any one. The link to buy it, please follow the link which I've given in the description box. That is the link that you can follow in order to buy it on Amazon. A better idea would be to buy it on oswaldbooks.com website, because there what you can do is to use my author coupon code Sudhir10, with which you will get additional discount on any book that you buy from Oswald Books. So that is something which you can do in order to save money for your parents. I also must tell you, and this is very important, I will be doing test paper videos on every chapter of science and social science on this channel, CBSE with Sudhir. That will be coming up every chapter. There will be 40, 50, 55, 60 marks test paper depending on the chapter, which will contain all competency-based tricky questions so that you are well prepared for the examination chapter-wise. So that is something which I'll be doing here on this channel. So that is something which you should be looking out for. But if you are looking for a book which contains, now you may ask, why should we buy this book, sir? Because this contains notes, this contains mind maps, this contains all the answers to all the questions which are there in your NCERT textbook. It contains more extra questions and answers, plus it has 2 practice papers at the end. Okay, so if you are looking for that, this is what I would recommend more than any other book available in the market. And these are the things that you need to do. Look into the description box for the details. Okay, let's move forward. Particles, please understand, irrespective of the substance, the particles in it are always in constant motion. Okay, now, but there is a difference. There is a difference between the particles which are there in this stone, the particles which are there inside this water, and the particles which are there in the air around me. There is a difference, and that is what we will be studying about in this particular chapter. Now, is there a difference in the way the particles move? What I just now told you. Yes, there is. This is a solid, this is a liquid, this is a gas. What is the difference? In solids, the particles vibrate in fixed position, so that gives solids definite shape and volume, which is why this particular piece of wood is exactly like this. It is solid because the particles are vibrating in fixed position. They are not moving away from their position. They are there where they are. If I'm here, I will be doing everything here only. I am not moving anywhere. So it gives me a fixed kind of position. It's almost like attention position, right? I am not moving much. So there is not much of vibration. Even if there is vibration, it is in a fixed place, which is why I am a solid substance. Okay, but in liquids, the particles slide past each other. In liquids, what happens is that the particles, each of these particles, they're sliding past each other. So how do you remember it? When you step on, let's say, a puddle of water and you step on it, the likelihood of you slipping is very high. So it is because the particles slide past each other. That is what is happening out here. While that gives definite volume, it gives a certain volume, it gives its indefinite shape. Because they slide past each other, a liquid never has a particular shape. It takes the shape of the container. The water bottle, earlier it was in the water bottle, right? It was earlier in this water bottle. Earlier the water was here. From here, it was in the shape of this particular bottle. From here, I poured it into this glass. So now it has taken the shape of this glass. Why? Because it does not have any kind of shape of its own, because the particles slide past each other. In the case of gases, and any gas, we are talking about oxygen, carbon dioxide, nitrogen, whatever, particles move freely and rapidly, resulting in indefinite shape and indefinite volume. Air is all around us. It has no volume, it has indefinite volume, and there is indefinite shape. So that's because the particles move freely. Okay, I hope this is clear. This is at the heart of this particular chapter. Behavior of matter depends on the size of the particle, the interparticle spaces, what I told you in the case of water and sugar, and the interparticle forces of attraction. This is something, again, a new concept I'm going to tell you about. So it depends on the size of the particle. It depends on the space between two particles. Okay, interparticle spaces, the space, and it depends on the interparticle forces of attraction. It does not necessarily mean magnet, but the magnet has been used in the illustration to show the forces of attraction. Okay, now I'll explain it to you. Forces that exist between atoms or molecules of a substance are called interparticle forces of attraction. This is the definition that you need to remember. Okay, so this is between the two, whatever forces exist that are known as the interparticle forces of attraction. In the case of solids, the forces are very strong, which is why it is giving definite shape and definite volume, right? Locking particles into a fixed position. Now, this is in the case of a solid. Both of them are very close together, right? But in liquids, the forces are weaker. They are not so strongly with each other. दोस्ती इतनी गहरी नहीं है. दोस्ती इतनी गहरी नहीं है. They are a little far away from each other, while they are very weak in the case of gases. So the interparticle forces of attraction are the weakest in the case of gases and the strongest in the case of solids, and that is what gives them a certain shape, a certain volume. Okay, I hope this is clear. Now, what decides different states of matter? So the interparticle attraction that we just now spoke about, the attractive forces that hold constituent particles together, the strength of these forces depends on the nature of the substance. Depends on the nature of the substance, what is the strength of these forces and the distance between the particles. So the scenario, if you are seeing very close, this is a solid. But if there is a slight increase in the distance between the two, that means the interparticle forces of attraction that decreases, and this will become a liquid. This force of attraction decreases because the distance between them increases. This is in the case of a solid. This would be in the case of a liquid in comparison. Okay, so even a slight increase in the distance decreases the interparticle forces drastically. It is inversely proportional. Increase in the distance means the interparticle forces decreases. Increase, decrease. So I hope this is clear. Now, a small box which is there in your textbook. Ancient Indian philosopher Acharya Kannad first proposed that matter is made of tiny, indivisible, eternal particles called Parmanu. Okay, so this particular word you can remember, it can come as a fill in the blanks, as an MCQ or a true or false kind of a question. So he basically called it Parmanu. Now let's move to solid state in more detail. Activity 7.3. Hammering objects like iron, nails, stones and wood shows that they are difficult to break, because their particles are held strongly together. So you would find nails go ta, 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 you have to hit because they are very solid and strong. They are strong, which is why, because the particles are held very closely together, which is why you have to apply more force to drive a nail into the wall, or to break a stone, or to break a piece of wood, right? Or to do any other activity on any other kind of a strong object. Solids have a definite shape and volume because particles are tightly packed in fixed position and can only vibrate from there. From this position, this blue particle can only vibrate. This blue particle cannot come to the place of the green or the yellow particle. It will stay here, which is what is giving it a definite shape. Now, let's come to the concept of melting. What happens when solids are melted? Heating a solid makes particles vibrate more vigorously. So when you apply fire, when you increase the temperature on a solid, for example, if I start heating it up, what will happen to this block of wood? What will happen is that the particles which are there inside this particular solid block, they will start vibrating more vigorously. Aag lagegi to you will start vibrating, right? Until they leave their fixed position, at which point in time that blue particle that I spoke about, this blue particle, it will start moving and coming in the place of the red particle or the yellow particle or this blue particle, right? So it will keep moving its position if temperature is added, right? And at that time the solid can become a liquid. For example, a piece of ice cube, right? An ice cube, if you keep it outside the fridge, outside the freezer, even at room temperature, even if you're not providing heat, there is the atmospheric heat, the pressure, the temperature outside is less than inside the freezer. So because of that atmospheric heat, or if you provide some heat, it will start melting and becoming water. It has moved from solid to liquid because the particles are now vibrating more and vibrating and moving away from their fixed position into a position where they are sliding past each other. Is that clear? Now, so the definition of melting point, which is 0 degrees Celsius in the case of water, is the minimum temperature at which a solid melts to become a liquid at atmospheric pressure. At atmospheric pressure, room temperature, where a solid melts to become a liquid, that is known as the melting point. That's a minimum temperature required. What is low melting point and what is high melting point? When solids have weak interparticle forces of attraction, it means they have low melting point. That is, very quickly they can actually melt, right? Like ice, it has a low melting point. Very quickly it can melt and become water. Its melting point is only 0 degrees Celsius, right? So it means they have low melting point, which means that in the case of ice, the interparticle forces of attraction between two particles is very weak. So thoda sa bhi heat laga do, it will melt almost immediately. Whereas in the case of, let's say, a piece of iron like this, the melting point is 1538 degrees Celsius, which means you need to give it that much of heat. When solids have strong attractive forces, interparticle forces of attraction. This is wrong. Interparticle forces of attraction, like iron, whose melting point is 1538 degrees Celsius. Okay. Let's now move to the liquid state. See, nobody will teach you in so much of detail. I can give it to you in guarantee. Lot of people do a lot of tamasha. I don't do tamasha. I'm telling it to you, making it as interesting as I possibly can in a digital format and explaining it to you in detail so that there is absolutely no doubt at the end of this class. Now, activity 7.4, we are talking about transfer of water. Pour 200 ml of water into different shaped containers. What I told you, right? For example, I have a bottle of this shape, right? I have poured and it has taken this shape. I have another bottle of this shape, right? So this is a smaller bottle and it will take the shape of this bottle. And then, of course, I have this particular glass. I have also brought this particular container. So I've got a whole lot of things from the kitchen. Okay, so the water level stays at 200 ml, but the water takes the shape of whichever container it is. So it has these kind of different beakers which have been shown in this illustration. This is one beaker, this is a tall beaker, this is another shaped beaker, right? So liquids have a definite volume but no fixed shape. Interparticle attractions are slightly weaker than compared to solids but more than compared to gases, allowing particles to move past each other. I hope this is now clear. Now, let's move to another concept called the boiling point. My throat is beginning to ache. The temperature at which a liquid turns into vapor at atmospheric pressure, that is known as boiling point. So, understand the concept of evaporation, the slow process of vapor formation that occurs at the surface of a liquid at any temperature below its boiling point. So, when you are boiling, let's say, water, okay, you will see a lot of vapor is actually going up, right? Because it is just about to reach boiling point and a lot of it is actually going as water vapor. Similarly, if there is a puddle of water and there is a hot sun, you will find that over half an hour, 1 hour, the puddle of water will disappear because of the heat of the sun. That is known as evaporation, the process of evaporation. Third, let's move to the gaseous state. Smoke is trapped in one jar, right? This is one jar and you have trapped it and you have closed the lid and there is gas inside. It's a smoke filled jar. Now what you do is to get another jar, open the lid of the jar and you immediately put that jar on top of it. Okay, now this one has some gas inside it. This one is an empty jar. Okay, at least we can't see anything, not that we could see, but sometimes we could put some colored gases and we could see this gas. So then we see that this smoke will move upwards and fill this jar also. So what is really happening is that smoke is trapped in one jar and another jar is placed upside down over it. The smoke spreads and fills the entire space of both jars. The conclusion that you arrive at is that gases have no fixed shape or volume, unlike solids, and to an extent unlike liquids, and occupy all available space. Interparticle attractions are negligible. The interparticle attraction between two particles is almost zero. It does not exist, which is why it is able to move anywhere, unlike in the case of solids. Okay. What are fluids? Substances that can flow and do not have a fixed shape, specifically liquids and gases. We do not include solids as a fluid. Liquids are a fluid like oil, the oil that you use, the engine oil that you use in your vehicle, or any kind of liquid or any kind of gas can be classified as a fluid because it does not have a fixed shape and it can flow anywhere. Okay. Now, how does interparticle spacing differ between solids, liquids, and gases? Okay, let's look at activity number 7.6. We take a syringe without the needle. Okay, you block one end with your thumb and you push the plunger. I hope you have seen it. I could have got it. It would be lying somewhere at my house. So if you have a syringe, you block the thing, you remove the needle and you block it, and you move the thing and you try to compress the portion which is supposed to have air in between. The plunger moves in easily. The plunger moves in easily, right? Here there is air, but it is able to move in, and the volume of air inside this space, it actually decreases. If you try this with water, it won't be possible because the water will try to go somewhere. The water will try to go somewhere, right? It is actually not possible to compress it. So the conclusion you arrive at is that gas particles have a lot of space between them and can be forced closer by pressure. So you can, because there is a lot of space between each of the particles, when you apply pressure like this, you can bring them closer together. So the volume of the air here will actually decrease. Now, activity number 7.7. When sugar is dissolved in water, what we did the experiment right at the beginning of this explanation video, the volume of solution is less than the total volume of the sugar and the water combined. That is, the volume of the solution is less than the total volume. That if you have water, let's say 100 ml, okay, and then you add sugar cubes also, which also have a certain volume, right? And then you expect that this will be more than that. That does not happen, right? That does not happen because the dissolved sugar particles occupy the interparticle spaces. What I showed you at the beginning of this video, they are coming and occupying the spaces in between, right? So it's not adding to the overall volume of the dissolved sugar solution. So when I put sugar into this, if you are expecting that I had water till here and then I put 1 spoon or half a spoon of sugar, so the volume should increase, that will not happen because the sugar particles have gone and occupied the space in between the interparticle spaces of the water, right? So that's the reason why the volume does not increase. Already present between the water particles. Why does sugar dissolve and sand does not dissolve? Now, this is a question which you are very likely to get in the examination. So this is the answer you need to give. You can take a screenshot also. Sugar dissolves in water like this because its particles are attracted to water molecules. So there is an attraction between the sugar particles and the water molecules. The water molecules surround the sugar particles and pull them apart, allowing them to mix evenly throughout the water. So that allows them to occupy the spaces between them because there is a sense of attraction between the sugar and the water molecules. In the case of sand, it does not dissolve in water because its particles are not attracted strongly enough to the water molecules. Water cannot separate the sand particles, so they remain unchanged and settle at the bottom. So sand, you will never find it being able to dissolve the way sugar can. It goes and deposits itself at the bottom of the glass, of the container. The attraction depends on the nature of the molecules involved. So in the case of sugar, there is an attraction. In the case of sand, there is no attraction, which is why sand is not dissolved and it deposits at the bottom, whereas the sugar dissolves in the water. Activity number 7.8, how particles move in different states. Now, if you add potassium permanganate, we have discussed this in class 6 and class 7 science chapters also. So if we put potassium permanganate in a bottle of water, in a glass of water, we see that the pink streaks spread from the grain until the whole tumbler becomes pink, right? We said that the entire water becomes pink in color because of the small potassium permanganate streak that we have put. The conclusion is that water particles are in constant motion. We have seen they are constantly slipping past each other, and they hit the potassium permanganate streak, which is a solid, to spread them throughout the liquid. And from there, they take it and they spread it across the liquid. And very soon, the entire water becomes purple in color. Now, the effect of temperature. What is the effect of temperature that you find? Now, particles, the basic funda that you need to remember is that particles move faster in hot water than in ice cold water. Okay, why is that so? Particles move faster in hot water because they have more kinetic energy. Kinetic energy is the energy of motion, the energy that gives them momentum. When water is heated like this, its molecules absorb energy, the H2O, they absorb energy, and they begin to move very rapidly, more quickly. Whereas in ice cold water like this, the molecules have lesser kinetic energy, so they move around very slowly. So particles move faster in the case of hot water. They are going very slowly in the case of cold water, ice cold water. So the other experiment that you need to do, activity 7.9, is to light an agarbatti, an incense stick, in one corner. When you put it in the puja room, you will find very soon the entire puja room is smelling of the same fragrance of that particular incense stick or agarbatti, right? Eventually fills the whole room with fragrance. Why is that so? Because air particles are moving constantly in the room and they help spread the fragrance particles. So because the agarbatti is in one corner at the puja room, despite which, because the air particles are constantly moving around, the fragrance is spread across the entire room. So if we have to look at this in a tabular form, the three states of matter, the spacing in the case of solid is minimum, right? We are just doing a quick recap, quick revision. Minimum. In case of liquids, it is more than solids, and it is maximum in the case of gas. Here it is very tight, there is no spacing. Here comparatively there is more spacing, and here there is maximum spacing between the particles. Packing, they are very closely packed, they are slightly loose, they are absolutely free particles. Attraction, the attraction is maximum, the attraction is weaker compared to solids, and here the attraction is almost zero, negligible. Movement, they only vibrate in their fixed positions, they are in a restricted space, whereas they move around all over. There is no restriction at all in the case of gases as far as movement is concerned. Now, this is something which is just preparing you, but we will study about this more detail in class 9 and class 10. The actual names for the tiny particles that make up all matter is atoms and molecules. Independent particles like water are called molecules, while elements like iron are made up of atoms. Its symbol is Fe. Iron is known as Fe for ferrous, right? Which we'll study more in class 9 and even more in class 10. Okay, so this is atoms and molecules. You just need to be familiar with it. Now let's look at some questions and answers, because these kind of reasoning questions and answers you are likely to get in the examination. Why is it possible to pile up stones or sand but not a liquid like water? Because stones and sand, like if I have these kind of stones, of course it's difficult to balance it can fall down, but if you arrange it in a very clever kind of manner, you can actually arrange it like this, right? Why is it possible? Even sand, you can make a sand castle like you make in a beach, at a beach. Stones and sands are solid, their particles are tightly packed, but liquid like water like this are loosely packed that move freely, so they cannot be piled up in any manner. Why does water take the shape of folded hands but lose that shape when released? Now, if you put water, you can lift from a bucket, you can lift water and you can hold it in your palm, right? If you don't leave any space, you can keep it for a long period of time, but it will keep trickling because there will be some space between your fingers. So water takes the shape of folded hands because liquid takes the shape of the container or space that holds them. When the hands are opened like this, the water obviously goes down and flows under the influence of gravity, because the Earth's gravity, it goes down. So the water loses the shape of the hands. Here it is in the shape of the hands, but once you remove the hands, the two palms, the water falls down because of gravity. We cannot see air, so how does it add weight to an inflated balloon? Now this is interesting. Air cannot be seen, but it is made up of particles that have mass. When a balloon is inflated, extra air enters it like this, right? Increasing its mass, since gravity acts on this, and because weight is essentially mass at a particular place, be it Earth or Moon or Venus or Mars, since gravity acts on this and added mass, the inflated balloon weighs slightly more than an empty balloon. So this is because of the air inside it, right? Because of the air inside it, an inflated balloon will have some mass, whereas this one has no air inside it, so therefore its mass will be less than this particular one which has air inside it. Is the air we breathe today the same as existed thousands of years ago? Very interesting question. The air we breathe today is not exactly the same air that existed thousands of years ago, but many air molecules have been continuously recycled and remixed in the atmosphere. So some of the molecules we breathe today may have existed on Earth for a long time, and some dinosaur also may have breathed the same air that we or you are breathing today, right? So isn't this very fascinating? So this is another interesting question. If you found this particular video useful, like the video to express your appreciation. Sharing is caring. So what I want you to definitely do is to do good karma by sharing the video on your class WhatsApp groups or with your other friends who are in other schools, etc. And definitely subscribe, because only then you will get to know what are the new videos, test paper videos, etc. that we are posting on this particular channel. The entire science for class 8, social science for class 8, English for class 8. All these three subjects I will be covering in detail out here, and this will be the quality of the teaching, which will basically ensure that by the end of the video, you are not left with any kind of doubts. Okay, Tata, bye bye. Thank you very much. Class 9, the channel is Win with Sudhir, where I will be teaching English and social science. Okay, Tata, bye bye. Thank you.